What is up? Mic check, mic check. 1, 2, 3. Okay. YouTube Studio says everything is excellent day. Excellent. I can live with that. Yeah. And my email says the same. Cool. Can I some? Let me real quick make sure I don't accidentally dox myself. That would be cool. Does this work? Case. Alright, let's move over here. Let's see how this sounds. I don't like this one. I'm not a big fan of this kind of music. Let's just play some video game soundtrack. Ice Sports. Okay. Let's check our levels. All right, everything good? Whew. Seems to be the case. And I already. Okay, so basically what we are doing, peeking a bit, lower this a bit. Is this better? I feel like this would be better. Sorry about that. So basically this is the Roslyn code generator that Ryder creates, right? So let's have a look at what this actually does so that we can try to understand what's going on. So we have this sample source generator, which is an ISO generator. which has an execute method. If you would like to put some data to non-compilable file, ATXT file, mark is presented file. Go through all files marked as a file in file property. How does this work? README. Maybe this helps. .NET standard project which implements a sample source generators. You must build this codes. The IDE sample generators generator that creates C# classes based on a TXT file, domain-driven design, register, whatever this. Oh, I think yeah, this ubiquitous language is the stuff that domain-driven design uses to describe things, right? It's ubiquitous among all the stakeholders. It's a weird concept, domain-driven design in general. Source generator that creates a custom report based on class property. The target class should be annotated with the generator's report. Source generator sample. A project that references source generator. Note the parameters of project reference. They make sure that the project is referenced and set of unit tests for source generator. This way to develop language-related features to start with unit tests. How to use the launch setting JSON profile debug. Okay, Java text noise. Roasted. And we could also use the oh man, SharpLab. I think it calls. Yeah. Oh yeah, this one here. Where we can how did he do that? Danny. I think this. Oh yeah, this is actually. This is the function pointer example. That results. Oh, there you go. Syntax tree, I believe. Yeah. And now you can just click on a thing, right? And then you have this, and then you can see, oh, it's a class declaration with the identifier. And then you have a method declaration with an identifier myfunc, right? And then inside this, you have the body, and it has like an open brace token, expression statement, invoke expression, right? This is how this syntax tree actually works. So let's have a look-see in our test. Maybe we should. Maybe we should have a look at this before we look at the source code. Sure. Might help us understand what's actually happening. So create an instance of the sample source generator. Alright. Then we say C# generator driver. Okay, this seems to be some sort of utility for testing source generators, which might be interesting. I mean, I'm actually more curious about the incremental stuff. I'm not really sure I understand the difference between source generators and incremental source generators, but it seems to be that incremental source generators are just better, like faster, so I feel like I should probably use those if I can. I will have to figure that out, I feel like. So we create this driver, then we just say use an empty compilation sample source generator test. And sample source generator test is basically the assembly name. Alright, so it's this assembly test edition file. Not sure. I am not sure what this does. And then we say new compilation syntax trees, select the file to array. Run generators and update compilation. Okay, this comes first. Run generators, don't forget to use the new compilation rather than the previous. Out for new compilation. Okay. And then we get the generated files. And then we check that we have generated files, basically. So this is the ubiquitous language registry, which basically, like, ubiquitous language as you describe something in your project. You have a customer, product, stock, shop, employee, blah blah blah, and then you have this class that basically uses the generated stuff. So this is auto-generated, as you can see. Then you have the sample entity. This stuff, okay, this is used for the other generator, which uses like this report attribute to basically print out these properties, right? So this is what basically this test does. So it doesn't, so this test doesn't really check the content of these files, what's in here, which in my opinion for code generation is kind of important. I mean, it's important that this is something that you should check, definitely, that these things exist, but also like what's the content. But in this case, the code generator actually doesn't do anything really interesting inside the file. So let's have a look at the sample source generator itself. So we have the execute function, right? And then we have these so what this does, it feels like context file, additional text files, and this is pretty much this, right? Yeah, this extends addition. Okay, so we extend this additional text, so we can just add our text file, because text files usually probably not being considered for source code generation because they are not source code. So we need to make the compiler aware of this, and this is done by basically setting these test additional files, right? Okay. So then we have our source code generator. Where was it again? Let's see. So we check if, okay, why would it be now? But okay, better safe than sorry, I guess. Then we check if the file name is the file that we are looking for, which I guess sort of feasible. And then we go through each of the lines, right? And then for each of the lines inside this ubiquitous language registry basically represents like a thing, right? And then we just go through each of the things and generate one class. So this is our class name, which is like just a string inside the file. See? And then we basically just put an empty which does nothing, so you can't really, like, you could basically check if this is inside the file, and I think the test of the incremental what should we call it, incremental source generator actually, so this is pretty much straightforward. It doesn't really interact with like the source code. It just uses a text file like this. Also, I mean, there might be use cases for this kind of stuff even inside Unity, right? Maybe you want to, like, I don't know, like, let's say you have some sort of asset that you want to generate like code for. This could work, right? So let's have a look, see at, first of all, let's try to run this test first. Run. So we are only running this, right? Cool. So this works. So now let's look at the incremental source generator test, which also isn't like really big. So let's have a look. See. First of all, we have the vector class text. So this is basically the source, I would assume, for our code generator. This is a vector 3, right? So this is like just any class basically, which has 3 properties: get, set, and then we have like a generator's report attribute on it, which is basically the attribute we are checking for to generate. So if we have a class that has a report attribute, we generate basically our code, and this is basically what the expected output for the code generation is. So we have a class file which has like this auto-generated comment in the header, then we have like using namespaces. Now this is this needs to be identical to what we generate. So if I would change, let's say I were just changing a tab here, this shouldn't most likely, yeah, it doesn't. So let's rerun this. Now it should begin again fully. Okay, so this is how it works. So that's a very simple way, right? You just define your input and hard code the output that you want, which is like, I feel like it's generally a good approach to code generation. So basically I would probably start by just writing a static version of the stuff that I want to do. So I would first, you know, you have a problem that you start with, let's say you start with vector 3, right? And your problem is you want to print it out, right? So what you do, okay, let's define a attribute that prints it out. And then you basically hard code a class that does what you want, right? So in case we want to, for some reason, yield return all the property for this class, right? It's one way to do it, I suppose. And yeah, now you have like your wish, your result that you wish for, and now you can basically now what I would do next is to write a test, right? That does exactly 2 things. It just takes the input, runs the code generator, and then it expects it to be this, and then it would fail, right? And then you just implement the code generator until it no longer fails, right? So that's something that you could call test-driven development, which, in my opinion, is just a cool tool for prototyping, especially for this kind of stuff. Like, if you were to actually develop this stuff directly in Unity, it would be so cumbersome. You would, first of all, you would have to, since this is a separate project, right? This generates a DLL file. You would have to, what should we call it? Basically compile this code, then move it into Unity, then load Unity, run Unity, and then it would probably fail, because let's be real, it's going to fail a lot. So this is like just a way faster way to run your code, and it has the benefit of you actually having unit tests. So if it breaks in the future, you might notice it. So I have to run to the bathroom real quick. Let me just let a notifier be so maybe, and yeah, I'll be right back. All right, I'm back. So let's keep on exploring. So as we already mentioned, these are like our input and our expected output. And now we are going to run the generator and see what happens. So basically the same as before. We create this generator instance and we use this C# generator driver. So C# compilation create sample source generator tests, which is the assembly. This part I'm not quite sure. Why do we use this. Let's try. What happens if we do this instead? Okay, so this is probably just a copy and paste error. So they copied this from the other source generator, and that's why I wasn't able to delete the other source generator. Okay. So basically, this creates a new compilation from scratch. Methods such as add syntax trees or add reference on the return object will allow to continue building on the complete. So it's the simple assembly name, and we are just using the name of this namespace here, or this class, as our assembly name. So we just have like a, could probably name it whatever, my cool assembly, I would assume. It should still work, I would hope. Yes, so this is, we can just name it whatever we want, because this only exists inside the you know, inside the context of this test. So we now take our okay, so this is interesting. This will take the vector class input and generate a syntax tree for it, which is something we need to know. So basically this allows us to just generate the syntax tree from a text tree, which so now C#, it's interpreted as C# syntax. So now the AST can be traversed. So then we have the system attributes. So to support system attribute inheritance, add reference to system private core lib. Okay, this is weird for me. So metadata reference create from file, and then we take object, which lives in like system, and then we take assembly, and then the location. I think I sort of understand what this does, but it's, so we need a reference to the assembly of system private core lib, which is weird because you would assume that the assembly of that object lives in would be like available everywhere, but I don't know what happens if we what happens. Oh, that's that maybe comment out this part. Let's see what happens. One or more child failed system sequence contains no elements. Okay, yeah, I guess this C# compilation doesn't know anything about the assemblies, so we need to actually feed it even the most basic assemblies. So that could be, that's an interesting thing to know. So we probably also need it if we I am not sure if we like use Unity stuff here. Do we need to add like Unity assemblies and shit like that? I'm not sure. We are going to have to figure that out on our own. So I would assume even like when we have our get generator like working in here, like in our tests, there's probably stuff we need to customize to fix for actually adding it to Unity. I know that there are some like assembly and assembly like project settings and stuff you need to make like in this C# project to actually get it to work. So that's going to be interesting. But now we can just say driver run generators, get run result, and now we can, let's see, run result generate trees. Okay, so this is like a generate the list of all the generated things, right? then we just, this is, I think this is link stuff. I don't really know much about link, but I would assume that this is like link to take like a single element where the file path ends with vector3.gcs, and we only have like one element supposedly. Like, I wonder if you could just do like maybe we expect to generate one file anyways. Okay, let's try debug. I'm curious what actually happens. It's not super important to understand basically like all the small details, but I'm still curious. So generated trees has 2. Test namespace, port attribute. Oh, the report attribute is generated as well. Interesting. Okay, so that's why we do this. Okay, I guess if you look at the generator a little bit, like, yeah, pretty much next, that should be okay. So that should be more obvious. So now we check like we do in the other stuff. So let's see, we do generated file syntax, which is like the reference you get here to a string. Ignore line ending differences. Yeah, okay, this can be very useful, because if you like run this on different like you could run this on pretty much everything, right, on in Unix or Windows, and if you have inconsistent file endings, that shouldn't break your test ideally, because line endings are just line endings, right? Okay, so this is basically the test. And now let's have a look-see at the actual code generator, which is a little bit more involved, it feels like. So let's just see. So here we have so I'm not sure why we do this. Like this will always result in the same so this is probably because I would assume I'm sorry, I have something good, but so this makes it very detached from like the project you're using the source generator in, right? Let's assume this is like running inside a Unity project. So in order to use it, you would have to somehow reference this attribute, right? So, and if this attribute would live in like the namespace of the source code generator, you would now have like this reference to the source code generator, which ideally the Unity project wouldn't even know that it exists, right? The Unity project should only care about the actual code that is generated. So what this allows us to do, I assume, is you just generate your attribute, like your report attribute, as part of the assembly that you generate your code into. So this this report attribute will now live in like the assembly of the Unity project, which I think is fine. What I like this, what I find a bit curious is like this stuff. Like, why is there a constant for the namespace and the attribute name, right? This is just like, maybe if you wanted to generate more than one attribute, that would make sense. But since this is only this one attribute, right, you could just say general something like that. Then you could replace this, and it should still work, I would assume. So let's run our Now let's first of all still in debug. Stop this. Need to debug, but yeah. So this works the same. So this might seem obvious, but I especially when there is like code generation, right? There is some sort of magic involved that it's not super obviously all the time, right? Especially when you work in like projects that use a lot of code generation, like shit just happens. In Unity, when you use the entity component system, attributes they just work. Attributes, aspects they just work, right? So, it's hard to just assume things. So like assuming, I mean, no, this is just the sharp string interpolation, right? But you know, better safe than sorry. So yeah, this is our source code for the attribute. Let's see. Where is the? Okay, this is okay. Let's not get ahead of ourselves. So let's just see what happens. So from what I've gleaned from the live stream that Danny was talking about this stuff, is that parsing these syntax trees is a little bit more involved. So we need to have a close look. So this is where we basically define, we add the generator for the generation for the attribute source code. So this code here is basically added to report attribute .c#, right? And this is the source code. It's done in YouTube. So this is basically straightforward as it gets. And I would assume, I wonder what's the difference between post initialization. Not sure. Which is the post initialization output? Can I generate context pass to an incremental generator? Not sure. Not sure what this would be. Maybe this has to do with like when the code is inserted, so that the other code generator can actually use this generated code. I would assume that's why it's post initialization output, and then we have source output, so that this gets added before this. That's just an assumption. I am not 100% sure. Then yeah, so then we go and check for the report attribute. So this is where things actually get interesting. This is where we actually look at our source code, at our domain source code, and look at where we can actually where we need to do stuff. So in this example, we have this sample entity, right? And it uses report, like, which is a generated attribute. This is the generated attribute. So we have the sample entity, and this is what we are going to be generating our report function. Now let's have a look. This is a partial class, which means that we can extend it with functionality. So let's have a look-see. So just two public fields, report attribute, partial class. So far, so straightforward. So let's have a look how we actually get that. So filter classes annotated with the report attribute. Only filter syntax node can trigger code generation. Not sure what that last part means, but I guess we'll figure that out. Context syntax provider. So context is the incremental generation initialization context. Okay. Then we create a syntax provider. Okay. Then we filter this for class declaration syntax. What else is there, like declaration? Okay, so here we go. We have a bunch of, we have accessors, constructors, delegates, enums, event, field, interface. So this is basically how you filter for the thing. So in this case, we want to just have classes, like class declaration syntax, right? And then we basically transform this get class declaration from source. So first we take the syntax node and then we do something with the class declaration for source gen. Oh, okay, this is basically a method that provided inside the generator itself. So let's see what this actually does. Checks whether the node is annotated with the report attribute and maps syntax context to the specific node. Class declaration syntax. So this is basically where the magic happens, right? Syntax context based on create syntax provider predicate, the specific cast and whether the attribute was found. Alright, let's have a look. We have a private static method that returns a tuple of class declaration syntax and a boolean report attribute found. And it takes in a generator syntax context. Okay, class declaration syntax basically takes the context node and casts it into a class declaration syntax, then go through all the attributes of the class. So how does this work? We have so this basically this irritated me when I was seeing it on the stream, right? Because of the missing indentation. In my opinion, this makes makes it a little bit more understandable what's actually going on. Or we could just, you know, actually add the brackets. So like for me, this makes it a little bit more obvious that we are actually like having nested loops, right? Not doing loop and then another loop, right? So go through all the attributes of the class. So this is the attribute list syntax. In attribute list. So this is basically a list of all the attributes. Very obvious. So we have report and basically it. And then okay, attribute list is a list of attributes on the class itself, and then we go through each of these attributes. Alright. And now we are looking for the semantic model get symbol info. So we're getting the actual semantic model for the attribute. I've never seen this kind of syntax before. Is not this makes sense to me. Context get symbol info is not I method symbol, but then you can also assign it to a variable. Is this what is happening here? I mean, it seems so, because we are now getting the attribute name. Ah, okay, and this is why we have namespace and attribute name in a variable, because we are using it here to check if this basically has this this attribute by using the fully qualified name, basically. So okay, and then we return the class declaration syntax, and we say, okay, true, we found the report attribute, or no, we did not report the report attribute. Okay, this is, I mean, every step here makes sense, right? So it's a little bit involved, but you know, that's like how, if you want to have like the power of like the abstract syntax tree, more or less, like, you know, knowing everything about the class, and you have to basically also handle every little bit, right? You have to first find the class itself, and then you have to take the list of attributes on the class, and then you have to take each attribute, and then you have to actually check, okay, what is the actual, like, now we only have the syntax, right? It says report, but we don't know which report is, like, what is it. So we need to get, like, this is the semantic meaning of that report, and then we compare that to like what we actually want. So we take the generated dot report and check if the name of the found attribute is actually generated the report, and then we know, okay, now this is our thing. Okay. So this is what get class declaration for source gen does. So this returns, then we run this. So this is basically, okay, I also don't like this indentation here. I don't know why a writer does this, because this sort of detaches it from, like, logically detaches it a bit from, I don't know. I just feel like the indentation makes it a little bit less obvious that this actually is called on the return of this created. But that's just me. I'm not a C# programmer like mainly, so I'm just not used to all of this stuff. So then we take this where, which is link, right? Sure. I think it is. Link, yeah, probably. So basically what we're looking for is if this report attribute found, which is set inside this method, actually is true, then we pick this this item. So this is what the syntax provider does. Now we have this provider contains all the classes where this is true, right? Not only one, it is run for each of these classes. Okay. Now we generate the source code. So what we are going to do here is we say context register source output, right? This is different than the register post initialization output. And what this does is compilation provider combine provider.collect. So I would assume all this does is basically, since this can be a multitude of classes that have been found, this now gets combined into a single thing for some reason. And then, okay, what's left and right? I have not. So then it calls this generate code method, right? Which is basically, why is it called left and right? What is compilation left, mutable array right? Is this what combine does? Okay, this is actually kind of confusing for me. Combine takes like two generics and collect. Not sure what collect. Yeah, this seems also this seems all to be like some weird link magic, which I honestly don't understand what it actually does. it seems to be combining two things, right? Because here we have like a compilation and a immutable array of class declarations. So, which is interesting because this is only like one compilation, but we have multiple class declarations. So, yeah, we are probably going to iterate over these class declarations. So let's say we have like 3 classes that all have the report attribute, right? Then we need to obviously generate code for each of these classes. So let's have a look what actually happens here. So get all filtered classes. Then we need to get semantic model of the class to retrieve metadata. So the semantic model we had earlier to basically check for the attribute itself. So class declaration syntax tree. Okay, then symbols allow us to get the compile time information. So this is the same syntax that we had earlier, which I didn't fully grasp. So basically this means that the result of this I am not sure I understand the syntax. But it seems to work, right? This class symbol is now available here. So this is this like a special thing related to this is not? So if not, else, right? Just like the shorthand syntax, I would assume, which is like, yeah, it's a C# thing. I haven't seen something like that in a different programming language, to be honest. So yeah, you learn, right? Then we have our namespace name, which we obviously need to generate our code because we want to put it in the same namespace because we're using partial classes, right? They need to be the same, right? You need to have 2 partial classes that are identical in name and namespace. Then we have identifier means the token of the node. Get class name from this. Yeah, identifier. This is what I've basically, showed here. This is the stuff, and this is where this stuff gets very helpful. Like if you need to, like let's say you want to, for some reason know which arguments a method has, right? So let's see. We have our method declaration here, right? And then we want to see, oh, there's a parameter list, and each of these has like 2 parameters, right? So let's add another one like in wool. So now we have 2 parameters in this list, bell and wool. Yeah, just this. Handy tool. All right. So this is how we get the class name. Well, we have a class declaration syntax, and we take the identifier, which is, usually the thing that names stuff. Like if this was a method declaration syntax, it would be the method name. It was like an attribute declaration syntax, it would be the name of the attribute. Right? And then you take the text, because we need text to basically, fill in our template later on. Go through all class members with a particular type to generate method lines. So this is interesting. Basically what this means that we only take properties, which basically, if my understanding of C# is wrong, which means you need to have something like this, where you have this get and set stuff. If I would just do public int foo, this wouldn't work. Okay, because it's not of type properties. So basically we take we go through all the members, then we take only the ones that are of type property symbol, And then we do a select, which basically allows us to map our output, right? So we have this property symbol, and then we return the source code for this particular property, right? So in this case, we generate this yield return, property name, this rename, right? And then this basically results in the generated stuff. I'm just curious. I was under the source generators. Should be able to just look at this is basically the output, right? We have this yield return ID. This is basically the string, and then this is the value. This is how this works. And then we take all of this stuff and basically put it into our code template. So we take the namespace, the class name, and then we have, this is fixed, right? This is always the same. And then we can just add it to the class, and which is done here. So we take like our class name and then just generate a .g.cs file. So in this case, this would be sample entity.g.cs, which you can see. And then we just say source text from, and then we generate our code, and then it's pretty much it. And then we have the sample project over here, which actually also uses the... Oh shit, man. Oh. Sneezy boy. So we have this example, right? So which just takes all our generated shit and then calls a report on it. Oh no, this is from the code generator. This is the incremental. So you can just now you have this sample entity, and you can just call the report method on it, even though it doesn't exist here, right? So this manages to just completely add a new method to something, which is pretty cool, I would suppose. Man, we have already taken an hour to just go over this stuff. So yeah, let me have a think real quick, but I think what I'm just going to do now is to just take some source code from my game. Let's have a look. And just use it as a reference, right? So we have our game code. So what could we... like, what's a simple component which also has like authoring? The problem is that I don't... I don't really have authoring for maybe this one. So we have this timer authoring, and then we have this timer component, which has like... yeah, this should be a good base, I feel like. So basically what I want to do is I want to take this, right, and then just be able to add a generate authoring or shit like that on top of this. and then the code should just generate. Which, yeah, which should be sort of straightforward, I believe. I hope. So let's go back into our source generator. And what I'm going, so I'm only using the incremental stuff, right? So what I'm going to do first is to delete everything. And we can keep this untouched. Let's just, I mean, no need to no need to do that, but like all the code that would actually get fixed, right? So let's just duplicate or maybe we should try to write this from scratch. Generate authoring test. Just to know, I feel like copying and pasting is obviously more comfortable, but you know, writing stuff from scratch 1 or 2 times can definitely be beneficial, right? So we have our namespace already set. We do not care about this stuff. Yeah, so it's called effect. X unit. Okay, this unit is X. Okay. Public void how do I call it? Like generate authoring. I don't know, behavior, and then just assert true, false. I don't know. It's just like, yeah, okay. This is just so that the setup works, right? Okay. All right. So, I mean, I'm going to copy this because I need to have like all the setup code. Code, and then like output, right? And then we need to check add class, and we're going to call this generate authoring host. Call it this way. And all this really needs as far as is like a generator tag, right? And it needs to implement the high incremental code generator, and this probably wants some methods. So let's try this. Now we can authoring code generator, and now this should of course fail, right? Because first of all, we haven't really set up like all our inputs, but it also should just throw an exception. So yeah, maybe the first thing we actually need to do, and I'm going to write as many tests as I generate attribute. Generates attribute. So what do we want the attribute to actually look like? So we could just have a look-see in here. This is like one server. So how does this add something like that? I'm not sure how does this work. Add and then quote. Okay. Var expected attribute output. Nice and long names. So what do we want? We want a generate authoring attribute. This is what we want. Okay. So how do we get this? We want to have like some sort of like generated output, right? And then we want assert equal generated output, which is the expected value. The first one. So let's just do this, right? So we want to compare those things, and this should obviously be broken. So because this is obviously not the same as this. So now we need to actually implement the code that actually does this. So this is going to be our let's see, maybe we can put this aside. Setup method, is there something like that? Setup. Let me have a quick Google X unit setup. Must be a simple way. Test. So then this approach when you want to clean test context for every test without sharing objects. I could just use the constructor, right? Sorry about that. But can I just use the constructor for the setup? So if I use, so what can we actually, I think we can do this. And put it in our constructor. Then we can refactor this a field and refactor this into a field. And I guess this as well. So now we only have to say run generators. Boop, boop. And then we can get this shit going. So we just do this. In here. Right? And we want our generate authoring edge file. That's how we're going to call. Okay, now this should still obviously fail because we still haven't implemented the actual generation. But it seems to not sure. Let's let's just try to implement the actual initialization of the attribute. We can old stuff. Okay, so let's have a look. We want to now we need to basically do this stuff. This is basically all we do. Hold on. We need to call this generate authoring, right? And then all we need to do is take our um, um, our test expectation. I can just copy this. Private string attribute source code. And this, no, I'm just doing everything pretty much statically here. This is probably going to change over the time. I'm actually considering maybe moving this shit into its own file, but just not for now. It shouldn't be too much of an issue. So now theoretically this test should be green, and it's not. Okay. Oh, that's because okay, I have a typo in the file name. This could be a reason. And it was. And now we are actually generating our first bit of source code, which is amazing. Amazing. Okay, so far so good. You know what? I actually want to put this into its into its own like file template. I don't know, can I just add like a attribute source code, something like this, and no, just do the stuff that is here. Then instead of doing this, by the magic of AI, I hopefully can just code attribute source code.txt from this. AI, do your thing. AI even on? Sure that it is. Don't know. It doesn't. File read all text. Now we can just do this. We've now refactored our code. Do not do file IO in analyzers. Oh. I see. Okay. That kind of sucks. I'm not gonna lie, but it's understandable since we are compiling this whole stuff into a to a DLL file. It totally makes sense. Off. Oh, that's World of Warcraft. By the way, how is the stream actually? Okay, yeah. Okay. I haven't really checked that, but right. So just in case anybody is actually watching and wants to has any questions or stuff like that, you know, just shoot. Uh, uh okay, so this is how we need to do it. Apparently, no text files. There's probably a way to somehow load a text file and embed it somehow, but I'm not going to not going to be going down that rabbit hole. That is it. Okay. Now, what do we need? So this was our first test, right? So now we generate our attribute, which is cool. I love this song. Beautiful. Beautiful. Okay, now what I want to do is I want to basically take like something like this. Maybe just a very simple version of it. And whoops. And generate code from it, I guess. So let's just make it very obviously var component code. Just paste it in and let's just do like one property. And then we need to do like, I don't know, using, I don't know, let's not do it like this. Let's do generated and generate authoring. So this is our source component code. Okay. Now let's have a look at the am I going to split up Baker and authoring? So let's take all of this expected code. edge, like one more. And then we also do this. Ba ba da 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 da. Yeah, there needs to be a better way to do this than having like all these huge strings, because this will be a pain in the ass if I need to refactor something. So this is our expected offering, so we need to, this should be like what turn. And then we need to have like timer offering. Change the base. Let's call this test. Basically the same, and then we have timer offering. Timer offering. It needs to be the same name as the class file, right? I am somewhat sure. So if you run this should of course fail because we are implementing. Okay. Going to yes. Let's just copy this whole shebang over here. I am just a dirty copy paste. Meeting. Okay, then we need this stuff over here. Create the generate code. And this to attribute found. Okay. So this now should at least call the generate code method. Basically copy all of this in here. Oh, okay. Named properly because I also. Okay. So now we need to actually have a look at what we. So this is pretty simple for now. We can just basically put code in a way. Let's have a look. In a way, let's call this authoring body, right? Now we need to figure out indentation. So basically what we're going to do is just copy this line one by one. And now we actually need to replace these things. Now, what we are going to need to do later on is to actually convert stuff like game object into entity and shit like that. But for now, let's just try to, you know, to just get a very basic source generation going, and then we do like \n for like a new line, right? Or maybe we don't, we can just... Okay. Now what we need to do... This is... Oh, okay, we don't need this in here for now. Then we take all of like so. And then we need to replace some stuff in here. This. Then we do, what did they do? Join. For the authoring body. And then all we need to do is to call this method here. Text, last name, authoring, and this in theory maybe should work. Okay, it does not work. Sequence contains no element. Yes, I know why. Because what we need to do now is we actually need to do this stuff here, right? To add here so that it's actually that the source generator actually knows that as source code, not only. So let's see if does something now. Nope. Sequence contains no elements. That's just such a helpful error message. Timer authoring. Okay, let's just add a breakpoint here and fuck this. Rated trees. I actually have one, but this is only this. And debugging this stuff can be a little bit painful. So let's see. Now we have to. This looks promising. Partial passive growth. Okay. Generators. Generators and generate authoring. Generators, generate authoring. Oh, that needs to be. So first of all, okay, we have multiple issues. This needs to be here. First of all, then we also have the. It uh, shouldn't maybe yeah, I know what issue because we are checking for struct. Let's for now only support structs because we really care about managed managed components, so we only want to support struct components. I wonder what would be the best way to support like both classes and structs in this situazione. Okay. Sequence contains the elements. Okay. Let's have a look-see. Wait. Let's name this. Why is this not called? This is confusing me. Oh, not this one. This one. Let's see. Class declaration syntax. It's the wrong name, but it doesn't really matter. We have attributes list, which has generators.generate authoring. Oh, okay, this is. Yeah, I should have. We used a variable for this stuff. You would assume that the guys at JetBrains actually know what they are doing when they're setting up these examples, right? So debug. Why? I want to listen to a little song. Even though it's going to get me demonetized.
Every night when the sky turns red up above, I feel the beat in my veins and I'm searching for love. You know that hips don't lie and leave you hypnotized. Just give me one more try to make you
ba, 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 ba. Offering generator. Okay. Okay, attribute name, generators, generate, offering. Alright, so this should hopefully fix it. Boom, boom, boom. Boom, boom, boom.
Here for the moment, here for the beat, here for the love and the friends I need.
Alright, space test. Yes. Yes.
I'm here for the moment, here for the beat, here for the love and the friends I need to know that I'll be there for you.
Okay, let's just run this. Okay, this is probably just a... Yeah. Okay, we need to go... And this is why we write test. This is... So now we have the issue with our line endings. Ignore line ending differences. Okay, let's go back to the not demonetized music, but let's maybe skip this one. Okay, so let's have a look. This. Oh yeah, iProperty symbol is of course wrong. Was haben wir denn da? Where something shared accessibility public. I mean everything should be public basically, but okay, now we have too much indentation. Basically need to do it like this, right? This is like the finicky stuff. Imagine you had to debug this in Unity. And there you go. So this should now of course downside is that I haven't yet set it up to work in Unity. So I can't really test it in Unity, but that's something we're going to check out the next time, which is probably going to be tomorrow. Because I am going to go to bed right now. It was a very productive stream. Hopefully some of you guys might stumble upon this stuff in the future and find it useful. I mean, it's a super niche thing. It's probably not going to be relevant for most people, even though I think that it could be very useful for a lot of people. But yeah, I just like to play around with stuff like that. I feel like this could be like, I'm going to open source this stuff, and I feel like it could be a very very useful library. We get back our generate authoring component that we used to have, which I feel like is just super useful, if at least to prototype, right? You just define your component and then you slap the generate authoring on top of it, and then you can just use it. I feel like this might be very helpful. I hope at least that it would be. If not, it's at least a great learning experience, right? So I wish you guys all the best. Make sure to like and subscribe this channel. Like the video, subscribe to the channel. Yeah, if you have any feedback or questions, just post them down in the comments below. I will pretty much read all of them, as long as it's not getting too much, but I am not afraid of that going to be happening very soon. So yeah, I see you guys around. All the best. Bye bye.